Okay, so we're going to start at the very beginning about trig functions. Okay, so taking us back to geometry, hopefully you remember a saying called SOHCAHTOA. So this is how I usually write SOHCAHTOA. So of the SOHCAHTOA stands for sine. So sine of an angle, which we're going to call theta, is equal to your opposite over your hypotenuse. And where this is if you have a right triangle, right? Pretend that this is a nice right triangle, and you have an angle in one of your corners, okay? Based on this angle, right, the opposite side would be right here because it's opposite of your angle. Your hypotenuse is always your longest side, so this is your hypotenuse, H for hypotenuse, and adjacent just means that you're next to something. So here is your adjacent side, right? Depending on where your angle is, so let's flip, again, my horrible looking right triangle. So if I put my theta there, again, my opposite will be now here at the bottom. My hypotenuse is still the same, and adjacent is over there, right? So again, C stands for cosine. So cosine of an angle is adjacent over hypotenuse. And then T stands for tan, or tangent, is opposite over adjacent. Okay, so how do you actually get these values? Well, if you remember from your right triangle days in geometry, right, we use these as legs, and sometimes you're used to saying them as A, B, and C, and so you used A squared plus B squared is equal to C squared. So the Pythagorean theorem. Okay, so that kind of helps us figure out what's happening with the missing leg. So as long as I know two legs, I can find the hypotenuse. If I know a leg and a hypotenuse, again, I can find the missing leg. And then when I use trig, that kind of helps us trying to figure out what our angle is. Okay, we do have three more trig ones, and these are the reciprocals to sine, cosine, and tangent. So technically, sine's reciprocal is what's known as cosecant, and it's just your hypotenuse over your opposite. Your cosine's reciprocal would be secant, that's your hypotenuse over adjacent, and tangent is cotangent. So these are your reciprocals. Now, when we're dealing with our trig, when it's just in a pure right triangle form, we can use opposite, hypotenuse, and adjacent. But a lot of times we graph these trigs with a number line. Okay, so what happens if I draw something, and let's see if I can draw it a little bit better. So I draw an x-axis and a y-axis, and I'm going to say my starting point is always 0, 0. So, so here's my lovely graph. So what happens if I have a point on this ray, right? So starting point's at 0, 0. And again, we don't know what this point is. We're just going to call it x and y. Okay. Technically, I can make a right triangle if I draw straight down towards my x-axis. Okay. Now, this value, this would be your x. This value right here would be your y. So we're going to use different letters instead of A, B, and C. And we're going to call this hypotenuse this time, we're going to call it R. Okay? Because all of our trig comes from what's known as the unit circle, right? Which will eventually be used to seeing. And our unit circle equation is just a regular equation for a circle. X squared plus y squared is equal to r squared, where your center is at the origin, right? 0, 0. So again, this is very similar to our a squared plus b squared is equal to c squared. Okay, this time our theta, though, always starts at our positive x-axis and goes towards our ray. So this is actually our theta. Okay, so instead of using your opposite, adjacent, and opposite, adjacent, and hypotenuse, we're going to use our other letters. We're going to use x, y, and r. Okay, so this time we can see sine of theta is, again, it's going to be a y over r. And our cosine this time is going to be the x over r. And tangent this time is going to be y over x. Okay, and we have, again, the reciprocals. Cosecant of theta will be r over y. Cosine will be secant of theta, so this will be r over x. And tangent, reciprocal is cotangent, and then this is x over r. Things to remember is that y can never be 0, x can never be 0, and that r was not supposed to be an r, that's supposed to be a y. Sorry. Change that to a y, so x over y. And here, also, y can equal 0, and here x can equal 0. Your r is never equal to 0 because your r is talking about distance. Okay, so it's a point that, so you're letting x and y be a point other than the origin on a terminal side. So this is what's called a terminal side. So initial side is down here. Terminal side is right here in standard position. And then your 6 trig functions are defined as follows. So why am I talking about this? The reason why I'm talking about this is so this will help us try to figure out some fundamental identities that will help us verify our trig. So let's get into the fundamentals. So fundamental identities. I'm going to bring back the fun in fundamental. Okay, so our first fundamental identity is known as the reciprocal identities. Okay, and since we have 6 trig functions, we have 6 of these reciprocal identities. So what we're going to say is that the cotangent of theta is the same thing as 1 over tangent of theta. Vice versa, the tangent of theta is going to be the same thing as 1 over cotangent of theta. So they kind of are very similar to each other. I can also say that, the secant of theta is 1 over the cosine of theta, or vice versa, cosine of theta is 1 over secant of theta. And then last but not least, the cosecant of theta is 1 over sine of theta, or we can say this, sine of theta is the same thing as 1 over cosecant of theta. So why do these reciprocal identities actually work out, right? Why do we know that these are true? Well, let's take a look back at how we defined our trig using the y's and r's and things like that. So let's prove this guy right here. So I know that the sine of theta is going to be y over r. Okay, why is that the same of 1 over cosecant? Well, I'm going to say 1 over, and cosecant is now r over y. All right, so division is the same as multiplying by the reciprocal. So instead of writing 1 divided by r over y, this would be the same thing as saying 1 times, and then flip my fraction, y over r. When I multiply 1 by y over r, I'm left with just y over r. So y over r is equal to y over r. So that's why these reciprocal identities always work, right? Again, it takes us back to our definition of our trig functions. Okay, so that's our first fundamental identity that you need to memorize. The second one is known as your quotient identities. okay? And you have two quotient identities. So the first one says that tangent of theta is the same thing as sine of theta over cosine of theta. And vice versa, I know that tangent and cotangent are reciprocals of each other, so that means cotangent should be the reciprocal of tangent, so it should be cosine over sine. Again, let's work this out using our, again, using the y's and r's and x's, right? Let's figure this out. So tangent is made up of y over x. Sine is made up of y over r. I'm going to write it like that. Divide by cosine, which is x over r. Like I said before, division is the same as multiplying by the reciprocal. So I flip my second fraction. Notice that the r's cancel out. And what do you have left? Y over x. And the same thing would work for cotangent, right? So x over y, and we would say x over r divided by y over r. Flip it. The r's are going to cancel out, leaving you with just x over y. Again, two more that go under the quotient identities. All right, our third identity is known as the Pythagorean identities. Okay, and there are three of these, so I'm going to call this number 3. So there are 3 Pythagorean identities. The first one is written like this: sine squared of theta plus cosine squared of theta is equal to 1. The second one is written as tan squared of theta plus 1 is equal to secant squared of theta. And finally, the last one is 1 plus cotangent squared of theta equal to cosecant squared of theta. That's it. So notice that we have none of the identities repeating. They all have a 1 in common. And there's multiple ways that we can actually write these identities. So I could move the cosine over to the other side. So another way that I could write this is sine squared of theta is equal to 1 minus cosine squared of theta. I can solve for cosine. So cosine squared of theta is equal to 1 minus sine squared of theta. So you don't need to memorize what's written in green. You need to know the orange and how to manipulate it. Okay. For tangent, right, plus 1 is equal to secant, I could say that tangent is equal to secant squared minus 1. That's one way I can write it. I can also say 1 is equal to secant squared of theta minus tangent, right? And again, I'm just solving for a positive one. I could, I guess, also solve for a negative one if I wanted to, right? I can, you know, here I can move the secant over. So there's a lot, again, different ways that we can write this. And so for the final one, again, I can say 1 was equal to cosecant squared minus cotangent squared, or I can say cotangent squared of theta is cosecant minus 1. So again, a lot of different ways that we can write this. So how did we actually come up with this way? Well, Pythagorean identities follow the rule of Pythagorean squared, the Pythagorean equation. But instead of using a squared plus b squared is equal to c squared, we're going to use the x squared plus y squared is equal to r squared. Okay, so the first thing I'm going to do on this one is I'm going to show how we get this. So I'm going to divide everything by r squared, because mathematically I can do that. And if I do that, I have an x over an r, right? So I have x over r, and all of this is being squared. Here, I have a y over r, and all of it is being squared, is equal to 1. Now, what is x over r? Coming back to this chart, right? X over R is cosine, right? And a Y over R is sine. So again, if I replace this, this becomes cosine of theta squared, and then this becomes sine of theta squared. Now you can write it like that. We tend to write it how it, again, it's written in orange, because we want to make sure that everything, the whole trig function is actually being squared, not just the theta. And then that's equal to the number 1. So again, that's just one way to write it. If I look at this guy, so x squared plus y squared is equal to r squared. So if I divide everything this time by x squared, notice x over x, that just gives me my 1, y over x squared, and then r over x squared. What is y over x? That's your tangent. Right? So again, another way that we can write it is that we square the entire thing. And then r over x, that's the whole thing of secant. Okay, so again, please make sure you either use parentheses or you write it like this. I'm mostly going to write it like this. All right, and then last but not least, x squared plus y squared is equal to r squared. So I've divided by x, I divided by r, so the only one I haven't divided by is my y. So if I divide everything by y, I'm going to get x over y squared plus 1 is equal to r over y squared. And what are these values? So again, this is your cotangent of theta squared plus 1, and that's equal to cosecant of theta squared. Pythagorean identities you use the most. All right, the last identity that you are going to see is known as the negative angle identity. Okay, and again, there are 6. So basically, this one we don't use very often. You only use it to pull out the negative next to your theta. So sine of negative theta is the same thing as saying negative sine of theta. And its reciprocal is exactly the same thing. So if I have a negative in my theta, I can pull all this out and just make it a negative cosecant of theta. Cosine is a little bit different. You have a negative angle, it's the same thing as a positive angle. So whatever that number is, it's the same thing. And its reciprocal is exactly the same thing. So secant of negative theta is the same thing as secant of theta. And then cotangent and tangent, actually let's put tangent first. So tangent will be the same thing as negative tangent of theta, and its reciprocal is similar. So again, this identity just helps us bring and make the angle positive again. So you really only have to worry about the cosine and the secant. Okay, so what can we do with these identities, right? We can use them to start to write easier expressions. Okay, so if I said to simplify these problems, our goal is to try to write an easier expression. So if I look at this and I say the secant of theta cotangent of theta times the sine of theta. I want to rewrite things. So I want to try to get this down to an easy number. When in doubt, I always say, write as sine and cosine. Everything can be always rewritten as sines and cosines. So I know secant would then be 1 over cosine of theta. Cotangent is cosine of theta over sine of theta. And the great thing about sine is that it's already a sine. So sine over 1. What do I notice? Again, here comes the algebra aspect. When you multiply fractions together, right, you multiply the numerators with the numerator, denominator with the denominator, and you can simplify. So if I have a cosine in the numerator and I have a cosine in the denominator being multiplied, get rid of it. Notice I have a sine in the numerator and a sine in my denominator. So this whole expression can simplify down to the number 1. Let's try another one. Let's try to simplify this one. So cotangent squared of theta, 1 minus, or 1, let's say 1 plus tangent squared of theta. Okay, so looking at this one, I see squares. Okay, and again, my goal is to always simplify it. Anytime I see an addition sign with a squared, my thought goes Pythagorean identity. So notice that tangent squared of theta plus 1, again, I can flip them around because 2 plus 3 is the same thing as 3 plus 2. Okay, so I can rewrite the tangent squared of theta using my Pythagorean identity. So I'm going to say, I'm going to change my color. So I'm going to say cotangent squared of theta, and now I'm going to multiply that by just secant squared of theta. So now I've gotten rid of my parentheses, and I've gotten rid of my addition sign. So what else can I do? Well, I know my cotangent. Again, I can kind of use my cotangent identity in another way too. So I know it just says sine over cosine, but I can also say that cotangent squared of theta is the same thing as sine squared over cosine squared. So if I want to make everything squared, I can do that. So again, I'm going to bring it down to sines and cosines. So this is really cosine squared over sine squared. And then secant, I'm going to rewrite this as just 1 over cosine squared. So what do I notice? Notice that the cosines cancel away, leaving you with 1 over sine squared. Now I could stop there if I wanted to, or I usually don't like fractions, so I can rewrite this as just the cosecant of theta. So either one. What else can we do? What other type of problem can we simplify? So what happens if I have two binomials? So secant of theta minus 1 times the secant of theta plus 1. Now this problem, it looks like it is a start of a Pythagorean identity. The only problem is it doesn't have a squared attached to it. So what do we do? Well, so what would happen if I said, x minus 3 and x plus 1? You would multiply. You would multiply your binomials. You multiply the x by the x by the 1. So secant times secant, that becomes secant squared of theta. Secant times 1, that just becomes secant of theta. Negative 1 times secant minus secant, negative times a positive gives you a negative 1. These terms cancel out, leaving you with secant squared of theta minus 1. That is part of your identity, right? Pythagorean identity. So notice that it was the one in green. Here's the one we can manipulate. So that's the same thing as just saying tangent. Tangent squared of theta. So again, a lot of different things that we can do. Let's use one with the negative angle. So let's do one more. So tangent of negative theta all over secant of theta. All right, so how do we simplify this? Well, the first thing I'm going to do is I'm going to pull out the negative. So I'm going to say that this becomes negative tangent of theta, and I'm going to say divided by my secant of theta, because I usually don't like to write it as an actual fraction. The next thing I'm going to do is I'm stuck, so I'm going to rewrite it as sines and cosines. So tangent, again, is made up of sine of theta over cosine of theta. And I know that secant is really 1 over cosine. Division is the same as multiplying by the reciprocal. So I'm going to flip my second fraction. And notice that the cosines cancel away. What does it leave you with? Negative sine of theta. Okay, so again, a lot of different things that we can use with our fundamental identities.